Good morning, my student. Myself, Dr. Kapil Sharma. Here I am presenting lecture number 3, Quantum Mechanics. Last two lectures, we have discussed the basic idea about quantum mechanics on the basis of black body radiations, Stephen's law, Rayleigh-Jean's law, and Wien's law. These are classical nature. After lecture number 2, I have discussed the Bohr theory and basic idea of de Broglie wave, wave particle duality, and certain principle. Now, let us we discuss after that are important because in quantum mechanics we are discussing in wave nature of light. Because in quantum mechanics we know how the electron behave in a atoms. It just like a wave nature. The wave nature of light that are the confirmation idea about by Davison and German experiment and some aspect based on the different parameters. Now again we introduce the new topic like a wave function. The content of the presentation is what is wave function, and we can explain on the wave function like a Schrodinger equation, time dependent and time independent. These are most important expression calculate de Broglie wavelength on the basis of Schrodinger equation. First of all, we understand what is wave function. As we know, do you know what is wave? Wave is a disturbance of medium, and how the disturbance of medium calculate in a particle nature. Because we have sought out and we have studied in quantum mechanics like a phase velocity and group velocity, and these are presently under is not our syllabus. So see, we can only understand the particle nature and wave nature can be understand on the basis of phase velocity as well as group velocity. Like first of all, wave function. In a water waves, the quantity that vary periodically is a height of water surface. In case of sound wave, it is a pressure. In case of electromagnetic wave, it is a electric and magnetic field. Similarly, in case of matter wave, the quantity that vary is a wave function. If we understand what is water wave, you can see here and there they are moving top to bottom surface. They have a point to different surface. We calculate the water surface. Another is sound wave, it is just a pressure. Another electromagnetic wave, they have electric vector, magnetic vector, they are mutually perpendicular to each other. Similarly, in case of matter waves, because we are discussing on matter waves, then matter wave, the quantity that vary is a wave function, because every particle it has a own wave function and describe all the possible parameter in this area. Wave function is a complex quantity containing real and imaginary part. Like if example, if psi is represent a wave function, if psi is equal to a plus b of any function, you can ask, you can define the any function like sin x, cos x, you can choose any function, but it satisfy the condition of the wave function. If I is the imaginary parameter which depend upon the spatial coordinate like r is a Cartesian coordinate like x, y, z, and with respect to time coordinate. The value of wave function has no physical significance, but a wave function psi with its complex conjugate psi star, it gives the probability of the particle of an interval like x, y, z and other parameter. Because if we have a only function psi is equal to a plus ab, but we also require the complex conjugate, the probability of the function like x, y, z, the psi star d tau like dx, dy, dz. If we calculate, because psi star ka the imaginary function is always real and positive, a should be a plus ib multiple of a minus ib, that is a square plus b square. So we can say that the wave function should be normalized, real value and always continuous. We can understand by the different method the value of probability lie between 0 to 1. That means we can understand what is the meaning of 0 to 1. Let a intermediate probability 0.2. Suppose my result is 0.2, mean that 20% chance to finding the particle there. In that particular range like 0 to 1, 20% particle probability in this area. Although the value of wave function at any time or given space positive, negative, but its probability can always be negative. It is impossible. The probability cannot be negative. It always positive. If we because these are parameter are very essential requirement for our quantum mechanics, because wave nature, because we can understand by the wave nature of particle nature. So some properties of wave function are therefore as follow. Number one, the wave function is finite. It should be finite value, like single value and continuous. Number two, the first partial derivative of space, like del psi upon del x, del psi upon del y, del psi upon del z, is finite, single value and continuous. Third, the wave function must be normalized, is that psi must be like, because we have a Cartesian coordinate, x limit x, the limit of x is equal to plus minus infinity, y limit to plus minus infinity, z equal to plus minus infinity to be vary. Another, the probability of the particle, if like a function x1 to x1, y1 to y1, z1 to z1, psi square should be finite and constant value should be proper. That means it is implied that the wave function is not normalized. It can be normalized if divided by under root c. Like x1, y1, z1, if we have a limit, suppose we consider particle is 0 to 1, they have a psi square is always 1 for normalized condition. If maybe orthogonal, then psi star like x1 to x1, it might be 0. The wave function be the solution of a Schrodinger wave equation. It must be prior condition. Okay, let me understand. It may be prior condition. So these are the basic property that can explain on the wave function. In 1926, Max Born, German theoretical physicist, one of the founder member of quantum mechanics, the first introduced the concept of probability of wave function. In 1954, he got a Nobel Prize of statistical interpretation of the wave function, because it is not a easy task. How? Because we know, as per quantum mechanics, we know that the particle nature, wave nature, both are present. In wave, the particle may be everywhere in the present. In quantum mechanics, it is impossible to specify with a certain location of the probability, but it is possible to again probability for observing it can given possible the value. These are the parameters. Hello everyone. My basically point, quantum is a dynamical theory like a Newtonian mechanics. If you understand like a Newton mechanics, Newton's basic law, first law, second law, third law, and other gravitation law, other law parameters, both mechanics description how the state of the parameter change with respect to time when force act on the particle. If we comparison just a small portion, in quantum mechanics, the state of particle like t is equal to 0 required complex wave function r into t, are the position coordinate with respect to time 0, is that infinite set number of corresponding to the wave function of every point. At t is equal to 0, may be infinite number of waves and particle may be exist in this region. But in a Newtonian mechanics, the particle at t is equal to 0 specified by the given initial state, the position and velocity is that two set number are required. We required position as well as velocity. But it is in this required, we have only wave function at every point. You can certify by this point, but you cannot certify by this point. Here, the wave function psi, that is represented by r into t, must be calculated from Schrodinger equation. These are the basic law. Schrodinger equation is the basic law to understand where is the particle, to locate the position, to locate the position parameter, to locate the energy eigenvalue, to locate the other position parameter. We required a wave function and can be solved by Schrodinger equation. Here, if we have position and velocity, to calculate the Newton's second law, because we know that force is directly proportional to mass into acceleration. These are the basic points. So these are basic difference between classical and quantum mechanics on the basis of wave function. The wave function of classical given problem in quantum mechanics contain all the information like position, momentum, energy, etc. About the particle that permitted by energy by the uncertainty principle, the expectation value of the physical observable quantity must be real because the experimental result quantity are real. So these can be understood on the basis of quantum. If we normally we can understand, if we want to study the particle nature, we use Newtonian mechanics. But if you want to define the position in the particle in a wave, can be explained on the basis of quantum mechanics, and that must be follow the Schrodinger equation. So here I am discussing the important wave equation like Schrodinger equation. Is a very important article for your examination point of view. The Schrodinger equation tells us the rate of change of wave function is completely determined by the total energy of the system. Here we just a formulation we calculate the Schrodinger equation on the wave function. There are two categories in this area, time independent and time dependent. The time independent Schrodinger equation we can understand and can be derived from a moving along one dimension by using classical differential equation, which is derived from second law of motion of mechanical wave from the Maxwell equation by electromagnetic wave. These are equation represented del square psi upon del x square 1 upon v square del square psi upon del t square. Psi is the wave function, v is the particle velocity, v is the speed of moving particle or wave is the motion. Let the solution of this equation. Now if we mathematical solve, because we understand these are differential equation, if we solve the mathematical equation, the solution is become like this: psi r position x into t, psi naught sine into sine omega t, psi naught sine omega, we put the value omega 2 pi nu, the frequency, the equation 2 become, and we differentiate partially with respect to t, then equation become this value del square psi upon del t square, again 2 pi square, this value. Again this value, putting this value in the equation number first, and equation become del square psi upon del x square plus 4 pi square v square upon x square psi is equal to 0. These are Schrodinger equation. These are basic equation, differential equation can be calculated on the basis of these parameter. In case of non-relativistic case, the total energy of the particle is a sum of the kinetic energy of the particle. We know that because we are taking just a classical approach, we suppose a particle are moving in term of wave function, that's total energy in term of kinetic energy plus potential energy. Kinetic energy p square by 2m plus u into x into t, x the potential energy, like equation number saying. On substitute the value equation number 5, the equation become Schrodinger equation. These are the Schrodinger equation. So these should be crammed to memory, and these are very important for your numerical point of view, because del square psi upon del x square plus 2m into e minus v psi h square, these are one dimension independent Schrodinger equation. These are Schrodinger equation. Here is represent h cross, that is h upon 2 pi. Again we have parameter like this parameter, by replacing if del upon del co represented by del, that is these are the mathematical operator, del upon del xi plus del upon del by day, del upon del zk, del upon del k, x position r, we can that it is a three-dimensional form time independent Schrodinger equation. Del square psi plus 2m into e minus v h upon h cut square psi will be is equal to 0. These are very important. If the particle are free to move anywhere, you can apply this equation directly and solve the all equation that are very important. Okay, understand? So again another part 2, that is time dependent Schrodinger equation. If the particle, suppose if the particle are moving with respect to time t, before that if the particle are moving in free to move anywhere in the box, like we will discuss in later on, we can derive Schrodinger wave time dependent equation from its independent wave equation by eliminating from E from T. Like we have a Schrodinger, consider a wave function like is complex conjugate, like psi is equal to psi naught e to the power minus I omega t. These are first of all we differentiate the equation number first with respect to t, again with respect to t, again differentiate with respect to t, and we put the value del psi upon del t, psi naught this value, because these are the parameter eliminated by psi. we can I minus ka I omega psi into x pi del psi upon del t minus ka I e upon x co del psi upon del t. Substitute the value of E psi and above equation time independent Schrodinger equation. We put the value and get the result. These are same category like a time dependent Schrodinger equation. You can also by other methods calculate, but these are very simplest method because only we required a one equation first of differentiate with respect to s with respect to t and putting this value and become the Schrodinger equation. It is a Schrodinger time dependent wave equation is one dimension box of the particle. It can be given the three-dimension motion of the particle by del upon del x, this value. These are time dependent Schrodinger equation. So these are very important equation, time dependent and time independent. In case of free particle, we apply the potential will be 0. In case of free particle, potential will be 0. So physical significance, what is the use of physical significance of wave function? Here that is very important application. The Schrodinger equation is used to find the allow energy level of quantum mechanical systems such as atom and transition. These associate wave function give the probability of finding the particle at a certain position. These solutions should become describe the quantum aspect of the system. So these are important parameters, can be calculate the particle in a system and describe the position of particle as well as momentum of the particle as well as other property of the particle can be calculate is wave function. So my dear student, these are very important article for your examination point of view. Schrodinger time dependent or time independent are coming a different area in different field, and that every interview question that are based on this Schrodinger equation. So we can understand by this equation we calculate the all complete information like our particle nature. Thank you very much. Next slide we'll discuss the application of Schrodinger equation. Okay, all the